So hi guys, mayong adlaw. Welcome to NatzMath TV. So for today's video, my presentation is about finding the sum of terms of a geometric sequence, or it is what we call a geometric series. So when we say geometric series, it is the sum of all the terms in a geometric sequence. So for example, we are given this geometric sequence 2, 4, 8, and 16. So we have this geometric sequence with, of course, a common ratio of 2. But when we say geometric series, it is adding all the terms in a geometric sequence. So this becomes 2 plus 4 plus 8 and plus 16. So this is now what we call a geometric series by just simply adding all the terms in a geometric sequence. So in finding the sum of terms in a geometric sequence, we have these two formulas to use. So we can use any of these two formula. By the way, this formula is only used if the sequence is a finite sequence. So this is finding the sum of terms in a geometric sequence if the geometric sequence or if the given geometric sequence is a finite sequence. So in this case, we have the first formula. So S sub n equals A sub 1 times 1 minus r raised to n, that's over 1 minus r. Or we can use the second formula, which is basically the same to the first formula, that is S sub n equals A sub 1 minus A sub 1 times the r raised to n over 1 minus r. Again, this formula is a formula to use if the geometric sequence is a finite sequence. So if our sum of the geometric sequence, of course, is denoted as S sub n, and our first term is A sub 1, and of course, our common ratio is r, and that the common ratio should not be equal to 1. Okay? So let us start with the first example. For the first example, we are given this sequence 20, 10, and 5 until S sub 6. So meaning we need to find the sum of all the terms from 20 up to S sub 6. So in finding the sum of terms of this geometric sequence, of course, we can use any of this formula. So for me, it would be easier for me to use the first formula. So we have 20, 10, and 5. So we will identify the given. In the formula, we will need A sub 1. So we have here our A sub 1, which is the first term, is equal to 20. Then we also need our common ratio. So how to get the common ratio? We just simply divide, starting from the last term here, which is 5. Actually, this is not the last term, but we can start from here. So 5, that is 5 divided by 10. Then reduced by 5, this will give us 1/2. Then another is 10 divided by 20, reduced by 10, this will also give us 1/2. So that means our common ratio is 1/2. Another thing is we have the n, or the number of terms. So our n, since we are going to solve for S sub 6, so our n here is 6. Next is, of course, we need to substitute this given to the formula. Our formula again, we have S sub n, so this becomes S sub 6 equals our A sub 1 is 20, so we write 20 times. We use this grouping symbol because we need to substitute the value for r here, in which case we will be using the parentheses. So we copy 1 minus, so we use the parentheses. Then our common ratio is 1/2. Then raised to our n is 6. That's over 1 minus r. So we have 1 minus our r is 1/2. Then this time we need to simplify. So we copy 20 times, we copy 1 minus. Now we need to raise 1/2 raised to 6. This is 1/2 raised to 6. So when we raise 1 to 6, that means 1 times 1 times 1 times 1 times 1 times 1. So we multiply 1 6 times. That will of course give us 1. Then for 2, we need to raise 2 to 6. That is 2 times 2 times 2 times 2 times 2. That is, we multiply 2 6 times. That will give us 64. And that's over. 1 minus 1 half is of course 1 half. So we write 1 half. We copy 20 times. This is assumed to have denominator 1 since we are going to combine this fraction and whole number. So 1 is assumed to have denominator 1. In this case, we need to find the LCD. We have 64. So 64 divided by 1, our LCD is 64. 64 divided by 1 is 64. Times 1 will give us 64. We copy minus. 64 divided by 64 is 1. Times 1 will of course give us 1. Then, that's over 1 half. We will continue here. So we simplify. We copy 20 times. That's 64 minus 1 is of course will give us 63 over, we copy 64 times, or that's over 1 half. So we multiply 20 times 63, that will give us 1,260. That's over 1 times 64, that is 64. Then over, we copy 1 half. This time, since we have a fraction in the numerator and another fraction in the denominator, we need to apply the rule in division of fractions. So we copy 1,260 over 64. We get the reciprocal of the divisor. So we have 1 half. The reciprocal of 1 half is of course 2 over 1. And after getting the reciprocal, we need to proceed to multiplication. So we copy the numerator 1,260 over 64. Then instead of division, we now proceed to multiplication. And 1 half, the reciprocal of 1 half is 2 over 1. Then 1,260 times 2 will give us 2,520. That's over 64 times 1 will give us 64. Then we divide 2,520 divided by 64. That will give us 39.375. So this is now our S sub 6 for this given sequence. So the sum of all the terms in this geometric sequence until S sub 6 will give us 39.375. Now let's proceed to our next example. For example, we are given our common ratio is equal to 2. Our n is 7. So if this is 7, so this is a sub 7, which is the last term. This is supposed to be the a sub n. Since we have the n, so that is a sub 7, which is equal to 192. Then, we are to solve for a sub 1 and s sub n, or in this case, we are to solve for s sub 7. So we have two unknowns here. Now, since in the formula for the sum, we will be needing our information for a sub 1. So therefore, we need to solve first for a sub 1 before we can solve for s sub 7. So to solve for a sub 1, we will be using this formula, which is a sub n equals a sub 1 times the r raised to n minus 1. So in this case, since we have the a sub n, in this case we have a sub 7, so 192, and we have the r and we have the n. So we can solve a sub 1. So we'll substitute this value. Our a sub n or a sub 7 is equal to 192 equals, we copy a sub 1 since we are going to solve for a sub 1, times our common ratio is 2 raised to 7 minus 1. So 7 minus 1 is equal to 6. So we copy 192 equals a sub 1 times 2 raised to 6. This time, we need to raise 2 to 6. That means we will multiply 2 6 times. So we copy 192 equals a sub 1 times 2 raised to 6 will give us 64. That means 2 times 2 times 2 times 2 times 2 until 6. Now, since we are only going to solve for our a sub 1, so we need to eliminate 64 at this side of the equation. So to eliminate this 64, we have to divide 64 at this side of the equation, and of course, we have to divide 64 at the left side of the equation. In this case, we can cancel out the 64, and 192 divided by 64 will give us 3 equals, what it means here is the a sub 1 or the first term. Or we can interchange, we can have a sub 1 is equal to 3. So therefore, our first term given r as 2 and 7 and the last term is 192, the first term is 3. We now be using this value to solve for s sub 7. So we substitute our formula, we have s sub n. Instead of writing s sub n, we will use s sub 7 equals. This time, we now have our first term, which is 3. So we write here 3 times. We copy 1 minus our r is 2 raised to n is 7. That's over 1 minus r. So 1 minus our r is 2. We simplify. We have 3 times 1 minus 2 raised to 7 is 128 over 1 minus 2 is negative 1. So again, 2 raised to 7 is 128. We subtract. So we copy 3, which is this one. 1 minus 128 is negative 127 over negative 1. This time, we will multiply 3 times negative 127. So 3 times negative 127 will give us negative 381 divided by negative 1. Divide, so we'll have s sub 7 is equal to negative 381 divided by negative 1 is of course positive 381. So this is now our sum of all the terms of the geometric sequence 381. So that's it. I hope you have learned something from this video. Please do not forget to subscribe, like, and share to your friends. Again, this topic is for junior high school mathematics, which is for grade 10 students. So for now, thank you and God bless.